All right, welcome back. This is our last section of this chapter that we're going to do. This is section 8.8. It's called Solving Radical Equations, and our objective happens to be the exact same as the title. It's to solve radical equations. Now, because this is our last section, we're going to have a PC in a couple of days. We will review the next day and then have a PC the following day. And then also, because it's the last section, once we're done with the PC, we'll do a chapter review and then take a chapter test. So that's coming up soon. And I'll make sure in class that you know what those dates are. We have one vocab word for this section. That one vocab word is radical equation. It's an equation that contains a variable within a radical, and it's important to note that we only want answers that give us a positive result. So remember, we can't take the square root of a negative number, so we have to be careful of that, and that's something we need to check for. We have some steps that we need to follow to solving these. The first step is to get the radical all by itself. That is extremely important. If you forget this step, you're going to make mistakes when you're solving these problems. Then, once you have the radical all by itself, you want to take both sides to the power of the root. In other words, you want to get rid of the radical. How do we do that? Well, let's think about that. If we're taking the square root, we're going to square both sides. If we're taking the cube root, we're going to cube both sides. If we're taking the fourth root, we're going to take the fourth power of both sides. And so we're basically going to undo the radical. Then we're going to solve like we're used to solving. And lastly, we're going to check our answer. So let's look at a few examples here. Again, pause this if you need to get it to get those steps written down. And let's see if we can get my computer to cooperate. There we are. All right. So we have these two problems, and we're going to look at them together first. And I've got several I want you to practice. But this first equation up here is 5 plus the square root of x plus 1 equals 16. Now remember that first step says to get the radical all by itself. The square root of x plus 1 is not all by itself. We have to move that 5. So how do we move it? We subtract it. But if I subtract it from this side, I'm going to have to subtract it from this side. And let me see if I can clean that 5 up a little bit here so it actually looks like a 5, so that when you're writing this down in your notes, you're not wondering what in the world you just wrote down. All right. Now, those are going to cancel. That's going to leave us with this square root of x plus 1. And then we also have to say, well, what is 16 minus 5? That's 11. Now we have the radical all by itself. So we have to undo the radical sign. Well, how do we undo a square root? We square it. But if we square this side, we have to square this side. The square root of something squared is simply what's under the radical. It's our x plus 1. 11 squared is 121. And now we solve just like we would. So we would subtract 1 from both sides. Those are going to cancel, so x equals 120. Now we need to remember to go back and check. So we go back to the original equation and we check it. And we say 5 plus the square root of 120 plus 1. And we want to know, does that equal 16? So we're going to put a little question mark here. Is that true? Well, square root of 120 plus 1 is the square root of 121 plus 5. That's 11. 5 plus 11 is 16. So yes, 16 equals 16. And it checks. Now, this one over here is another problem we need to look at. This 7 is outside of the radical, and we're taking the cube root, so that's going to be important when we're doing this. Now, this 7 is being multiplied. Again, we want to try to get that radical all by itself if we can. So what do we do to undo multiplication? That's right, we divide. So we divide by 7, and we divide by 7. Those are going to cancel. That's going to leave us with the cube root of 5x minus 7. And that's going to equal 84 divided by 7. 84 divided by 7 should be 12. Okay. All right, So now we have the radical all by itself. So how do we undo the cube root of something? We take the cube of both sides. Cubing a cube root simply gets rid of that radical sign. So I'm left with 5x minus 7. And now I need to know what is 12 cubed. I don't know that off the top of my head, so I'm going to use my calculator to help myself out. And we get 1,728. Now this is a problem like we would have in algebra. We need to take this 7 and move it to the other side. We do that by adding 7 to both sides. So we get 5x equals 1,735. For some reason, I am having a hard time with 5s today. Let's see if I can fix this. And make that a 35 that you can read. There we go. Now we're going to divide both sides by 5. All right. So x equals 1735 divided by 5. And I'm going to do that on my calculator, and I get 347. Now we need to check. So we have the cube root of 5x minus 7 times 7, and we think that that equals 84. So we have 7 times the cube root of 5 times 347 minus 7, and we want to know, does that equal 84? We're not sure, so we're going to put a question mark. Let's see if I can give myself just a little bit more room here. It's not looking like it, so we're going to try and squeeze it in here. I'm just going to talk it through and write the answer out because I don't want it to be too crowded for you. But 5 times 347 is 1,735. Minus 7 is 1,728. And so we have 7 times the cube root of 1,728. And that is 7 times the cube root of 12, which does equal 84. 84 equals 84, so that checks. It's really important that we check because sometimes an answer is not going to work. All right. Now, these have radicals on both sides. As long as there's nothing outside of the radical being added or subtracted, we can just deal with them the way they are. So this one says 7x plus 2, and this one says 3 times. We can square it even though it's being multiplied. That's what we can do. If it was an addition or subtraction, we couldn't do that. How do we undo a square root? Well, we square it. So we're going to square this side. And we're going to square this side. Undoing or squaring a square root simply leaves us with 7x plus 2. That's a plus sign. I'm going to try that again. We're going to square this side. And we're going to square this side. And so we have 7x plus 2, there, that looks better, equals. Now, the 3 gets squared. What is 3 squared? It's 9. Squaring a square root gives us what's under the radical, 3x minus 2. Okay? We need to make sure we distribute that 9 through just like we normally would. So we have 7x plus 2 equals 27x minus 18. All right, how do we solve this? I'm going to subtract the 7x from this side. And if I do it to that side, I have to do it to this side over here. Okay. Those are going to cancel. And I'm also at the same time going to excuse me, I'm going to add the 18, so my x is on the other side. I'm going to add 18. When I add 18, I get 20 here. And 27 minus 7x is 20x. Divide both sides by 20. And we get x equals 1. All right, now we need to check this. So we're going to put it back in and we're going to see, is the square root of 7 times 1 plus 2 equal to 3 times the square root of 3 times 1 minus 2. All right, 7 times 1 is 7, plus 2 is the square root of 9. This is 3. 3 times 1 is 3 minus 2. So we have 3 times the square root of 1. But what is the square root of 9? It's 3. 3 times the square root of 1 is 3. Are those the same? Yes, it checks. All right. Now, I want you to try this one on your own. Pause it, and then check back and see, did you get the same answer that I got? All right, let's try it. Are the radicals by themselves? Yes, because we're only multiplying, so that's okay. So what did you do? Hopefully, you squared both sides. Squaring a square root simply gets rid of the radical. So we have 8x plus 6 equals 3 squared is 9, because it's not under radical, and then we have 9x. So we subtract 8x from this side, and if we do it to one side, we have to do it to the other. So we get x equals 6. All right, let's check. This now becomes the square root of 8 times 6 plus 6. And that says that equals 3 times the square root of 6. 3 times the square root of 6 is not a perfect square, so we can't simplify that anymore. Let's see what happens when we get over here. 8 times 6 is 48. 48 plus 6 is the square root of 54. Well, let's break 54 down. 54 breaks down into 9 and 6. 9 breaks down into 3 times 3. And 6 breaks down into 2 times 3. Taking the square roots, we're looking for a pair. The 3 comes out. The 2 and the 3 don't have partners, so they stay home. They both stand the radical sign. 3 times the square root of 6 equals 3 times the square root of 6. And they both check. Did you get that answer? If not, what questions do you have about this? Now, let's try this one. This one's a little trickier, so we're going to work through this one together, and then I'm going to give you several practice problems I want you to try. There's a lot of these to do, but you can handle it. All right. We have the square root of negative 3x plus 33 equals 5 minus x. Radical is all by itself. Oops. The radical is all by itself over here. So we can just do the next step. It's the square root, so we're going to square both sides. All right. Now, when we square a radical, it simply gets rid of that radical sign. So we have 3x plus 33. Let's see if I can make that x a little better. There we go. Now, this side over here, though, there's no radical to get rid of. So I have to square 5 minus x. But that means I have to take 5 minus x times 5 minus x. Remember, when we square something, it says to multiply it by itself 2 times. So I have to FOIL this out. I have to take the first times the first. That's going to give me 25. The outside, that's going to give me a negative 5x. The inside is also going to give me a negative 5x. And the last, a negative times a negative, is going to give me a positive And x times x is x squared equals a negative 3x plus 3. Now, we have a squared sign and we have some x's in here. Haha! Guess what, guys? We're going to have to factor. You remember how to do that? We've talked about that so many times. And remember how I promised you it was never going away? Well, guess what? Here it is again. All right, so we're going to add the 3x to this side, and we're going to subtract the 3. We're going to subtract 3, and we're going to add 3x. Remember, because we like our squared term to be positive. Because remember, we have to set this equal to 0. All right, I'm going to rewrite these terms when I write them down so that it's in standard form. I have x squared minus 5x and minus 5x is a negative 10x plus 3x would give me a minus 7x, and 25 minus 3 would give me a plus 22. So now I need to ask myself, what multiplies to give me 22 and adds to give me negative 7? All right, did you find my mistake? What did I do wrong here? Right, way back up here, when I wrote this down, this should have been a 33. And so this should have been a 33. And so instead of subtracting 3, I should have subtracted 33 from both sides. And so instead of this being a 22 over here, 25 minus 33 should be a negative 8. It wasn't factoring for me, and I was trying to think about that. All right, so you guys are going to have to decide what's going to happen in class tomorrow because I didn't do this problem correctly to start with. Always be careful that you're writing things down correctly. Now we need to factor this side. So factor it. What multiplies to give me negative 8 and adds to give me negative 7? X minus 8 and x plus 1 will give me 0. Okay, now remember we set each of those pieces equal to 0, so we say x minus 8 equals 0. Adding 8, we get x equals 8, and we say x plus 1 equals 0. Subtracting 1 from both sides, we get x equals negative 1. Now, do you remember that last step? We said to check. We have to go back and check because we have to have positive numbers here. We are only looking for positive numbers here. So what happens when we plug an 8 in? There's the original problem. You should have it in your notes. So when I scroll down, you should be able to see it. When we go into the original problem, we get the square root of negative 3 times 8 plus 33 equals 5 minus 8. But 5 minus 8 is a negative 3. This is a negative 24 plus 3. So that's going to give us a square root of 9. But we only want the positive answer. Since negative 8 gives us a negative answer, that is not an acceptable solution. So negative 8 is not a solution. Let's check negative 1. We have the square root of negative 3 times negative 1 plus 33. And that equals 5 minus a negative 1. Negative 3 times a negative 1 is 3, plus 33, that's the square root of 36. And 5 minus a negative 1 is 5 plus 1, which is 6. Square root of 36 is 6. That is our only answer. Even though we had two possibilities, we had to check. 1 did not work, x equals 8 did not work, x equals negative 1 does work. All right, I have 4 problems here that I want you to try. As you're trying these, I want you to be really, really careful with them. I want you to practice them on your own, and we're going to come back and work them together. All right, we're going to work through each one of these. I'm going to work each problem over here one at a time. So this first problem here, is the x by itself, or is the radical by itself? No. So we have to move this 7. How do we move it? We have to subtract it. All right, let's change color so we can see it over here. If I subtract the 7 from both sides, this now becomes the square root of 2x plus 4 equals 13 minus 7 is 6. Now the radical is all by itself, so we're going to get rid of the radical sign. We undo a square root by squaring it, so we have to square this side. When we undo that square root, it goes away. Six squared is 36. I'm going to move the 4 over. They're going to cancel here. So I get 2x equals 32. Divide both sides by 2. And x equals 16. Now, because of space, I'm going to do a mental check. 2 times 16 is 32. 32 plus 4 is 36. Square root of 36 is 6. 6 plus 7 is 13. All right, did you get that answer? Let's take a look at number 2. What are we doing there? That's right. We have the cube root. So instead of squaring both sides, we're going to have to cube both sides. So we're going to take this and we're going to cube it. We're going to take this side and we're going to cube it. All right, cubing that 3 makes it a 27. Cubing this gets rid of that exponent. Excuse me, gets rid of that radical, so we have x plus 4. Cubing this side gets rid of that radical as well, and so we end up with 2x minus 17. We have to distribute that 27 through. So that becomes 27x plus 27 times 4. That would be 108 equals 2x minus 17. I'm going to subtract the 2x from this side and subtract the 108 from this side. But if I do it to this side, I've got to do it to the other side. So subtracting 2x here and subtracting 108 here. Here we get 25x equals, these cancel here. I guess I should have canceled those there. A minus 17 and a minus 108 is going to be a negative 125. And divide both sides by 25. And we get x equals a negative 5. Now again, let's double check. Negative 5 plus 4 cubed is negative 1. Can you have the cube root of a negative number? Yes, because you can take negative 1 times negative 1 times negative 1, and that will give you negative 1. So it's okay to have that. So this is 3 times negative 1, or negative 3. This is 2 times negative 5, which is negative 10, minus 17 is a negative 27. The cube root of negative 27 is negative 3. Negative 3 equals negative 3. It works. All right, let's check this last one. It's kind of our third one here. It's a trickier one. All right, we have to square both sides to get rid of the radical. We have to be really careful when we square this side. Gets rid of the radical easily for us over here. That becomes 2x plus 12. But this becomes x plus 2 times x plus 2. 2x plus 12 doesn't change, but I've got to FOIL this side out. X times x is x squared. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4. Guess what? We're going to have to factor. Told you it wouldn't go away. So we're going to move this 2x over to this side, and we're going to move this 12 over to this side. So that's going to cancel, because remember, to factor, we have to have it set equal to 0. So x squared, those are going to cancel, leaving you with plus 2x minus 12. Oops, but 4 plus a negative 12 is not minus 12. It is minus 8. So x squared plus 2x minus 8. How does that factor? It factors into x plus 4, x minus 2. That gives me x as a negative 4, or x equals 2. Now, what happens over here? 2 times negative 4 is negative 8 plus 12. That's a positive, but what happens over here? That negative 4 makes this negative, so we can't have that answer. This is our only solution. Let's double check. 2 times 2 is 4, plus 12 is 16. Square root of 16 is 4, and 2 plus 2 is 4. That is our only solution. Again, make sure that you check. All right, last problem here. Did you notice it's got a rational exponent? You can treat that one of two ways. I'm going to treat it as an exponent here. So I'm going to divide both sides by 4 because I want to get that by itself if I can. All right, so I now have x minus 5 to the 1/2 power equals 3. Now, what I really want is that variable, or that exponent, excuse me, to be 1. So what would I have to multiply 1/2 by to make that 1? Well, how about 1/2 times 2, or squaring it? And if I had written it as a radical, that would have been the square root. So I'm going to square both sides. Remember, if you take a power to a power, you multiply. What's 1/2 times 2? That's 1. Anything to the first power is just itself. X minus 5 equals 3 squared, but 3 squared is 9. I'm going to add 5 to both sides. And so x equals 14. Let's check. X minus 5 is 9. The 1/2 power of 9 is the same thing as saying the square root of 9. Square root of 9 is 3. 3 times 4 is 12. It checks, so that is our answer. Now, I know those are a lot of problems there, and I'm glad that you worked through those with me. That's all we're going to have for today. I do want you to remember what we need to do at the end of each lesson. We need to summarize what we've learned, and you need to write at least one question you have for me about the lesson. Have a great night. See you tomorrow.